Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having the good time, as I say always, yeah. So people, you can first of all let me know in the chat box if I'm audible and visible to everyone, right? Let me know people. Hello Priyanka, hello Sahana, hello Ashwarya, hi Siddiq, hi Manisha, hello Ashwa, hello Akida, hello Dev. Welcome back people. Hello Pooja, hello Akash, hello Anand. Welcome back people, welcome back. Good evening everyone, good evening. Just give me some green signal from the chat box first of all, so that I'll get to know whether I'm audible and visible to you guys, right? Let me know fast people, let me know fast in the chat box if I'm audible and visible to everyone. Welcome back everyone, welcome back to JEE Enthuse. Perfect people, perfect. Hello Faisal, hello Dev, hello Nobita, hello Arthur. Welcome back everyone, welcome back. So as you all must be knowing, tonight it's going to be our one more mock test of our complete chemistry for the JEE 2021. Yes. So people, I think this is the 22nd mock test which we are going to do tonight, right? Till now we are done with some 21 mock tests for the JEE 2021, right? And tonight it's going to be the 22nd mock test, yeah? So before starting the session, the ones who are new to the channel, let me introduce myself. Well people, my name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this JEE Enthuse channel. So please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, yes? So people, you can first of all let me know in the chat box if you are super duper excited for the tonight's session as well. Just let me know in the chat box, let me see the josh of the session first, right? Let me know in the chat box if you people are super duper excited about the session, right? A lot of fire symbols, a lot of red hearts with the plus signs are coming up, yeah? That's nice. Okay, so let's get going then. Let's get started with the Rank Booster JEE 2021 Complete Chemistry Mock Test number 22 with the first question, which is going to be on your screen in 3, 2, 1 and now. Look at the question carefully guys, look at the question carefully. Which of the following compounds will exhibit cis-trans geometrical isomerism, right? You need to see, you are given with 4 options and you need to see which one among all will be exhibiting what? The geometrical isomerism. Let me know its answer fast. Let me know its answer fast. Well, I can see majority of the people are coming up with option D, and absolutely guys, you all are perfectly right. It's going to be option D only, right? How come it's going to be option D? How do I check it? See guys, let me exactly tell you what are the conditions for the molecule to show geometrical isomerism, right? I'm going to note down the conditions for the molecule to show geometrical isomerism, correct? In the molecule, if I'll be selecting 2 centers, in the molecule, if I'll be selecting 2 centers like this, the first condition, there should be the restricted rotation. There should be the restricted rotation about these 2 centers first of all. So rotation about these 2 centers should be restricted, number 1, right? Let's say there are 2 terminal bonds attached with this center over here. Let's say these 2 terminal bonds are attached with these 2 centers, correct? What is the first condition? Rotation should be restricted, correct? Point number 1. Point number 2, these terminal bonds, this bond, this bond, this bond and this bond, they should be either present on the same plane, they should be either present on the same plane, or the plane containing these 2 bonds and the plane containing these 2 bonds, both the planes should be parallel to each other, right? This is the second condition. The first condition, rotation should be restricted between 2 centers, number 1, right? Second condition, these 4 bonds, they should be either present on the same plane, or the plane containing these 2 bonds and the plane containing these 2 bonds, both those planes should be parallel to each other, right? This is the second condition. The third condition, there should be different groups attached with this center. There should be different groups attached with this center as well. If any molecule follows these 3 conditions, You can clearly say that molecule is undergoing geometrical isomerism, right? Yes, people? So among all these cases, this 2-butene is following basically all the 3 conditions, as you can see over here. See, this is basically your butane, right? But2ene, right? Yes, people? This is over here CH3, correct? This is CH3 over here. Now, people, I have selected these 2 centers, right? So first of all, there is a double bond in between, so rotation is restricted. Rotation is restricted. First condition is followed, correct? This carbon is sp2, this carbon is sp2, right? So this is planar, this is planar. What does that mean? That means this bond, this bond, this bond, and this bond, they are present on the same plane, right? And at the same time, there are 2 different groups attached with this carbon, and there are 2 different groups attached with this carbon as well. So absolutely this molecule is going to show what? It's going to show geometrical isomerism, correct? Now 2 same groups are on the same side, so this is what we call a cis, and 2 same groups are on opposite side, this is what we call as trans. I'm sure it's clear to everyone, right? Yes, people? So option D is the one which is the correct answer of this question, right? Yes? Perfect. So let's move on to one more question. I'm sure that's clear to everyone. Let's move on to this one more question, people. The question was asked in this year JEE Mains examination, right? From this, you can get the idea of few more things. Can you let me know its answer? Consider the elements magnesium, aluminium, sulfur, phosphorus, silicon. The correct increasing order of their first ionization energies. Okay, you can let me know its answer as well. It's a very simple question, people. First of all these elements, magnesium, aluminium, right? Magnesium, aluminium, silicon, phosphorus, sulfur, right? Then we have got chlorine, and what else do I have over here? See, silicon came, phosphorus came, sulfur came, aluminum came, magnesium came, right? Silicon is not there, so let's remove this silicon over here. Even chlorine is not there, right? So let's remove this chlorine as well. So people, all these elements, these 4 elements, they belong to same period. First of all, we know it, they belong to same period, right? And we must know as we move from left to right in the periodic table, right? As we move from left to right in the same period, what happens to the ionization energy? Ionization energy increases, correct? So what is the expected order of ionization energies? This is the expected order of ionization energies, but this is not the actual order. This is the expected order, but this is not the actual order, right? What is the actual order? Actual order is like this: phosphorus, maximum ionization energy, then your sulfur, then comes your magnesium, and then comes your aluminium. This is the order. This is the actual order over here. This is the actual order over here, right? Okay. What is the reason for it? I think silicon is there, right? Magnesium, aluminium, over here should be silicon, right? Silicon is also given, so magnesium, aluminium, this is silicon over here. So this was the expected order. Now what is going to be the actual order? Actual order is like this. After sulfur, I'm going to write silicon. Then after silicon, I'll be writing magnesium. After magnesium, I'll be writing aluminium, right? This is the actual order. Why this is the actual order? People see, understand. If you look at the outermost configuration of phosphorus, it is 3p3 configuration, right? It's 3p3 configuration. If you look at the outermost configuration of magnesium, it is 3s2 configuration, right? And in order to take electron out from the half-filled configuration, you have to supply more energy. That's why the ionization energy of the phosphorus is absolutely greater than that of sulfur. And similarly, over here, you have to take the electron from completely filled orbital, right? Energy needed is more. That's why magnesium is going to have more ionization energy than that of aluminium over here. So which option satisfies it? Which option satisfies it? Phosphorus, then comes your sulfur, then comes silicon, then comes magnesium, then comes aluminium, right? Phosphorus, sulfur, silicon, magnesium, aluminium. So option 1 is going to be the answer of the question, right? Yes, I'm sure it's clear to everyone. Right, people? So let's move on to one more question. Then this is one more question, a very, very simple question. You are going to arrange them on the basis of their stability order, right? Just arrange them on the basis of their stability order. Let me know fast in the chat box what do you think about this one. Let me know fast, people. Let me know fast. Give it a try. It's again a simple question. It's again a simple question. Well, people, first of all, have a look. There's a positive charge on this carbon, positive charge on this carbon, positive charge on this carbon, right? Well, people, there is the oxygen over here, and this oxygen is absolutely going to have 2 lone pairs, right? So can I say this positive charge is in conjugation with this lone pair, right? Yes. If this positive charge is in conjugation with this lone pair, that means C is going to be maximum stable. C is going to be maximum stable, right? Yes. Due to the back bonding which is possible over here, due to the back bonding, or you can say due to resonance, this one is maximum stable. Now among these two, you can clearly say which one is more stable. You'll clearly say B is more stable than that of A, right? You can either use the concept of hyperconjugation, or you can simply use the inductive effect, right? You have got CH3 group attached over here, right? Electron donating group. It will decrease the positive charge on this carbon and its stability will be more than that of A, right? Or you can use simply the hyperconjugation case as well. Over here you have got 3 alpha hydrogens. Right here you have got no alpha hydrogens. Wherever alpha hydrogen will be more, hyperconjugation will be more, and wherever hyperconjugation is more, stability is more. That's it, right? So what is the correct order? The correct order is going to be C, maximum stable, followed by B, followed by A, right? So option A is the one which is correct among all. Yeah? Well people, one more question on your screen. Give it a try. Let me know its answer. The question was asked in 2020. Give it a try, people. Give it a try fast. Give it a try. Let me know its answer. And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Yeah? All right. Let's exactly see how this sort of a question is to be solved. Read the question carefully, guys. We have got a mixture of N2 gas and argon in a cylinder which contains 7 grams of N2 and 8 grams of argon. If the total pressure of the mixture of the gases in the cylinder is 27 bars, the partial pressure of N2 will be, right? So how this question is to be solved? It's a very simple one. See, basically, I'm given with a container. This is a cylinder which I have, and in this cylinder we have got 2 gases. One is your nitrogen, and at the same time one is your argon, correct? Let me represent nitrogen by 1. Let me represent argon by 2. Total pressure of this mixture is given to me. Total pressure of this mixture is given to me as how much? 27 bars, right? 27 bars. At the same time, few more parameters are given to us. We are given with the masses of, I'm given with mass of nitrogen and mass of argon. Well, mass of nitrogen in the container which I'm representing by W1, that's given to me as 7 grams, and mass of argon in the container which I'm representing by W2, that's given to me as 8 grams, right? So first of all, what I'll be doing, I'll be calculating number of moles of N2 in the container, which will be equal to mass of N2 divided by molar mass of N2, which is 28 grams per mole. The value comes out to be 1 by 4, right? Similarly, number of moles of argon is going to be equal to mass of argon divided by molar mass of argon. The value comes out to be 1 by 5, right? I got the moles of both the gases in the container, yeah? Now what am I supposed to calculate? I'm supposed to calculate partial pressure of N2. Partial pressure of N2. I need to calculate P1, which as per Dalton's law is equal to total pressure of the mixture multiplied by mole fraction of N2. Yeah, that's it. What is the total pressure of the mixture? That's 27 bars. Mole fraction of N2 means number of moles of N2, which is N1, divided by total moles present in the container, which is N1 plus N2. You need to solve this part. Every parameter is given now. N1 value is nothing, that is 1 by 4, right? Divided by 1 by 4 plus N2 value is 1 by 5. You need to solve this, get the answer. That's something which will be the partial pressure of N2 gas in the mixture. And people, after solving this, you'll be getting the value exactly equal to 15 bars, right? This is basically the contribution of N2 gas. This is basically the contribution of N2 gas towards the total pressure of the mixture, right? Which is something which I call as partial pressure of N2 gas. I'm sure it's clear to everyone, right? Exactly, it's an easy question, guys, right? Moving on to one more question then. This is one more question. A very, very simple question. The question was asked somewhere in 1992, my God. Hydrogenation of benzoyl chloride in presence of PD on BaSO4 gives. Can you let me know which reaction is this? Which reaction is this? You are basically doing the reduction of benzoyl chloride in presence of what? In presence of palladium BaSO4, sorry. Yeah? Do we call it as the Rosenmund's reduction? So from your benzoyl chloride, what you'll be getting? Benzoyl chloride during Rosenmund's reduction, it forms what? It forms aldehyde, right? It forms benzaldehyde. Is that? Absolutely. Yeah? Right, people? It is the Rosenmund's reduction, and your benzoyl chloride, it will definitely get converted into what? It will get converted into benzaldehyde in short, right? This is the reaction. This is the benzoyl chloride. I'm doing its reduction in presence of PDBSO4. I'm getting something as the benzaldehyde over here. So the question is done and dusted. Very simple question based on your NCERT, right? Okay, primary, secondary and tertiary amines can be separated using. Can you let me know its answer? The question was asked in this year JEE Mains. The question was asked in this year JEE Mains. Let me know fast, people. First of all, let me tell you, people. Let me tell you, all of you are perfectly correct. It's absolutely going to be option A. Option A is the answer of this question, right? Now people understand. Look at the question carefully. Primary, secondary and tertiary amines, right, can be separated using what? See, we'll be using para-toluene sulfonyl chloride, right? Remember, tertiary amine, it does not react with para-toluene sulfonyl chloride. First thing, it does not. This tertiary amine, it does not react with this substance, right? Number one. Number two, primary amine, it reacts with this substance and forms a solid. Even secondary amine reacts with this substance and forms a solid, right? So in the first two cases, when primary amine reacts with this substance, it forms a solid. When secondary amine reacts with the same substance, it again forms a solid, right? When this solid is reacted with KOH or NaOH, that means a base, right? And when this is going to react with the base, one of them is soluble, one of them is insoluble, right? See, the compound which we get after this solid reacts with a base, we'll be getting a compound, right? Similarly, this solid, when it reacts with a base, we'll be getting a compound. One of the compound among the two is soluble, one of the compound among the two is insoluble, right? Okay, so this is the test by means of which I can differentiate primary amine, secondary amine and tertiary amine. Isn't it clear, right? Well, people, have a look properly. What is the reactions happening? See, you are getting something like this when the primary amine reacts with your para-toluene sulfonyl chloride. This is the solid which you get, precipitate, right? On reaction with base, you get a compound which is soluble, right? Similarly, when secondary amines are made to react with the same substance, you get a precipitate, you get a solid which is insoluble. Yes? Correct? And there is no reaction in the third case. Yeah? Right, people? Simple? Simple, guys, right? Absolutely. Moving on to one more question. When 50 ml of 0.1 molar NH3 is mixed with 10 ml of 0.1 molar HCl, what is the pH of the resulting solution? Again, a very simple question provided your basics are clear. That's it. See, guys, first of all, I'm making what? I'm making NH3. I'm making NH3 to react with what? To react with what is it? It is HCl. Okay. NH3 with HCl, right? So what is something which I'll be getting over here? I'll be getting simply NH4Cl over here as the product, and with this you'll be getting water as well. Yeah? With this you'll be getting water as well. Very simple. Now, people, understand properly. First of all, at time t is equal to 0, am I given with the molarity of NH3? Yes. Am I given with the volume of NH3? Yes. I'll be simply multiplying these two things, right? What I'll be getting? Molarity of the NH3 multiplied by volume of it in milliliters. If I multiply these two, I'll be getting millimoles of NH3. 50 multiplied by 0.1 comes out to be 5. So at time t is equal to 0, when the reaction has not started, I have got some 5 millimoles of NH3, right? And how many millimoles of HCl do I have? 10 multiplied by 0.1. How much that comes out to be? That comes out to be 1. So I've got 1 millimole of HCl as well at time t is equal to 0. And this is going to be 0, right? Now, people, the reaction is already balanced. The reaction is already balanced. Now, understand. If I'll ask you which one is limiting reagent among all, you'll clearly say HCl is limiting reagent. If HCl is limiting reagent, then HCl would have got completely consumed in the reaction, and at the end of the reaction, you'll be finding some 0 millimoles of HCl in the container, right? Yes, you'll be finding some 0 millimoles of HCl in the container because HCl is the limiting reagent. As simple as that. Now, people, the question is almost done. See, 1 mole of your limiting reagent reacts with 1 mole of NH3. So 1 millimole would have reacted with 1 millimole of NH3. Initially, I had taken some 5. I had taken some 5 millimoles of NH3. But out of 5 millimoles, 1 millimole is reacting. So I'll be left with 4 millimoles of NH3 at the end of the reaction. Similarly, 1 mole gives 1 mole. So 1 millimole is going to give 1 millimole of NH4Cl. I got the millimoles of all reactants and products, right? At the end. Yes? Right? Now, people, since you got the millimoles, if I divide these millimoles by the total volume of the system, which is 50 plus 10, that is 60. I'm dividing this by 60. I'm dividing this by 60. When we divide the millimoles by the total volume of the system in milliliters, what do we get? We get concentration. So this 4 by 60, this 4 by 60, it is the concentration of NH3 at the end of the reaction. Similarly, 1 by 60, this is basically the concentration of NH4Cl at the end of the reaction, right? So finally in the container, what you will see, finally when this reaction will proceed, when the reaction will stop, finally you'll find you'll find NH3 concentration as this much, you'll find NH4Cl concentration as this much, right? Now people, look at it carefully, look at it carefully. What do we have at the end of the reaction in the container? We have got a weak base, and this is the salt of weak base with a strong acid. So in the resulting container, what do we have? We have got a weak base and the salt of the same weak base. Salt of the same weak base with a strong acid. With a strong acid, right? So do we call this mixture as the buffer? Do we call this mixture as the buffer? Absolutely. And which buffer this is? This is the basic buffer, right? It is the basic buffer. It is the basic buffer. And I hope you know how do we calculate the pOH for the basic buffer. I hope you know that. There's a formula for it. pOH is equal pKb plus log of concentration of salt divided by concentration of base. Right? This is how we calculate the pOH of the basic buffer. As simple as that. Well, people, pKb value is given to me as 4.75, right? Plus log of concentration of salt. What is the concentration of salt? It's 1 by 60. It's 1 by 60, right? Concentration of salt is 1 by 60. What is the concentration of base? That's 4 by 60, right? 60 gets cancelled out. So it's basically 1 by 4. Log of 1 by 4 means log of 1 minus log of 4. Is the equation almost done? It's going to be 4.75. Log of 1 is 0, and it's going to be log of 4. Log of 4 is 0.6, right? The value comes out to be 4.15. This is basically the pOH of the solution. But people, am I supposed to calculate pOH or pH? I'm supposed to calculate pH, right? So I'll be using the simple formula, pH plus pOH at 25 degrees centigrade, that's 14. So from here you can calculate pH as 14 minus pOH, which is 4.15. Solve it, get the value, right? That's something which I was supposed to calculate. Yes? Perfect? Perfect. Yeah? So finally the answer will be 9.85, right? I'm sure it's clear to everyone, right? Perfecto. Let's move on to one more question, guys. This is the question. Select the correct statement regarding the shapes of PCl5, BrF5 and IF5. All are square pyramidal, all are trigonal bipyramidal. One of the given compound is square pyramidal, one of the given compound is tetrahedral. Let's check it out too. So let's start with PCl5. Right? PCl5. How many sigma bonds? 5. How many lone pairs? 0. 5 sigma bonds, 0 lone pair. What is the steric number? Steric number is sigma plus lone pair. That's 5. What is the hybridization? That's sp3d. Which d orbital is involved in the hybridization? It is dz square. Right? Now what is the geometry? What is the geometry? Geometry is simply going to be what? Trigonal bipyramidal. Yes, it is the trigonal bipyramidal geometry. PCl5, it's a very common molecule, right? Then we have got BrF5, yeah? We have got BrF5 as well. How many sigma bonds? 5 sigma bonds. Lone pairs on bromine, 1, right? Steric number, 5 plus 1, 6. 5 plus 1, 6 means hybridization, sp3d2, right? See guys, 5 sigma bonds, 1 lone pair. It is going to be what? It's going to be square pyramidal, right? There are 5 sigma bonds, 1 lone pair, right? Isn't it going to be square pyramidal? Yes, it's going to be square pyramidal, right? Now people, at the end we have got IF7. IF7, as you all must be knowing, it's sp3d2, right? See, we have got 7 sigma bonds, 0 lone pair on iodine. So steric number over here is 7. So it's going to be sp3d3, right? sp3d3, right? And the shape is going to be what? Pentagonal bipyramidal. Yes, pentagonal bipyramidal. Now check the answer. What is going to be the answer of this question? What is going to be the answer of this question? All are square pyramidal. No way. All are trigonal bipyramidal. No way. One of the given compound is square pyramidal. One of the given compound is square pyramidal. Absolutely. This one is right. This one is right. Yeah? The equation is done and dusted, right? Right, people? Absolutely. And if you have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Okay, which of the following molecule in pure form is unstable at room temperature? Unstable at room temperature. First of all, this is a cyclic compound, right? Cyclic compound. Every carbon is sp2 hybridized. Every carbon is sp2 hybridized, right? Now at the same time, there is a complete cyclic conjugation, right? And how many pi electrons are involved in complete cyclic conjugation? 4 pi electrons. How many over here? 2, 4 pi electrons, right? How many over here? 6 pi electrons. Yes. Now people, 4 pi electrons, that means the molecule is going to be anti-aromatic. 4 pi electrons, the molecule is going to be anti-aromatic, right? 6 pi electrons, it's going to be aromatic. This one is following the Huckel's rule, right? So we know the stability order. Aromatic compounds are maximum stable, followed by non-aromatic compounds, followed by anti-aromatic compounds. So anti-aromatic compounds are least stable. So first and second, both are anti-aromatic at room temperature. So first and second are going to be very, very unstable, right? So that's it. Yeah? We were supposed to check which of the following is unstable at room temperature. It's absolutely going to be option D, right? I'm sure it's clear to everyone. Let's move on to one more question then. This is one more question. Okay. 1 mole of an ideal gas, 1 mole of an ideal gas expands isothermally, reversibly from 2 liters to 4 liters, right? And 3 moles of the same gas, expands from 2 liters to X liters and doing same work, right? And doing same work. What is the value of X? Isn't it simple, guys? Isn't it simple? How do we calculate work done in reversible isothermal process? Let me give you the formula first. Work done in reversible isothermal process is equal to nRT ln of V2 by V1. I hope you know it. This is the formula by means of which we can calculate work in case of reversible isothermal processes, right? Now first case, we have got 1 mole of an ideal gas, right? It's expanding irreversibly and isothermally from what? From 2 liters to 4 liters. So let me apply the same formula. So work done in the first case is going to be N value, number of moles, 1, right? R I'm writing as such, right? T I'm writing as such, ln of V2 by V1. V2 is final volume, which is 4. V1 is initial value, that's 2, right? This is the work done in the first case. And work done in the first case is equal to the work done in the second case. What is the second case? Second case is 3 moles of the same ideal gas are undergoing the same isothermal reversible expansion from 2 liters to X liters. It's going to be nRT. It's going to be ln of final volume divided by initial volume. Initial volume is 2 liters, right? The question is almost done and dusted. Yeah? What do I need to calculate? I need to calculate the value of X. So RT got cancelled. N value in the second case is 3, right? So over here, I'm going to erase everything. I'm going to write 3. And this nRT you need to erase. That's it, right? So it's going to be ln of 2 is equal to what? Is equal to ln of, I can write X divided by 2 raised power 3, right? Yes. So what do I get from here? I get 2 is equal to X divided by 2 raised power 3, correct? Yeah? Right, people? So from here, what do I write? I get something as 2 is equal to X cube divided by 2 2s are 4 2s are 8, right? So you get from here X is equal to 16 raised to the power 1 by 3, right? So this is going to be the answer. Yes? Right, people? Right? Clear to everyone? Clear to everyone, right? 16 raised power 1 by 3. You can write it like this as well, right? 16 you can write 4 square. That means it's going to be 4 raised power 2 by 3. 4 raised power 2 by 3 means option B, yeah? Perfect? Exactly. Well, Arshad, you can see the thumbnail. It's already updated, I guess. In the thumbnail, you'll get to know what is the tomorrow's plan on both the channels. Well, tomorrow, let me tell you, tomorrow at 10:30 a.m. on NEET Elite channel, I'm going to do some 100 questions from the chapter Equilibrium, right? And this is valid for NEET as well as JEE Main students. You guys can, everyone can join in, right? You guys can join in this session, okay? This is for NEET as well as JEE Mains, yeah? Okay. Moving on to one more, guys. Which of the following undergoes nucleophilic substitution exclusively by Sn1 mechanism? A very, very simple question. Let me know its answer fast. Let me know its answer fast, guys. You can solve this one. It's a very simple one, right? Which of the following exclusively shows Sn1 mechanism? What do you think about this? What do you think about this? People, if you remember, in Sn1 mechanism, what is the first step? First step is the ionization step, in which you get the carbocation. Then you see the stability of the carbocation, right? Wherever carbocation is maximum stable, that reaction goes through Sn1 mechanism, right? Now, people, look at all these substrates. Where do you get the stable carbocation? In the last one, you have got benzyl chloride. Right? If you take Cl negative out, you'll get the carbocation as benzyl carbocation. and the stability of benzyl carbocation is maximum among all the carbocations which we get in the earlier three cases, right? Yes? Right, people? Right, people? Yes? Perfect. It's absolutely going to be option D, right? From here, you're getting the benzyl carbocation, which is very, very stable because the positive charge on this carbon is right now in conjugation with the ring, right? So positive charge will be dispersed maximum in this case, due to which stability of this carbocation is maximum. So that's why this one exclusively, this benzyl chloride, it exclusively undergoes Sn1 mechanism, right? Yes? Perfect. Okay, what about this one, guys? JEE Main's 2019 question. I'm sure you can kill this one as well. I'm sure about it, right? See, during compression of a spring, I'm doing compression of a spring, right? I'm doing compression of a spring. Work done is 10 kilojoules. Okay, so first thing you all must be knowing, in chemistry, whenever there is compression, we say work is done on the system and W value is taken to be positive, right? Whenever there is expansion, we say work is done by the system, W value is taken to be negative, whereas in physics, sign conventions are reversed, yeah? See guys, understand now. During compression of the spring, work done is 10 kilojoules. During compression, work done is 10 kilojoules. Work done will be positive, right? So it's going to be plus 10 kilojoules. Correct? Yes? And at the same time, 2 kilojoules of heat escaped to the surroundings. 2 kilojoules of heat is escaping to the surroundings. That means 2 kilojoules of heat is going from system to surroundings, right? That means the system is releasing heat. Whenever system releases heat, Q value is taken to be negative. We know it, right? So Q value will be taken as minus 2 kilojoules. The question is done. As per your first law, delta U is equal to Q plus W. Delta U is equal to Q. Q is minus 2, W is 10, right? The value comes out to be plus 8 kilojoules. This is the value of delta U, which I'm supposed to calculate, right? Plus 8 kilojoules. Option 1 is the correct answer of this. It's again the easy kill question, right? Right, people? It's again the easy kill question. Yeah? I'm sure it's clear to everyone. Let's move on to one more question then. Okay, the correct order of the intensity of the colors of the compounds is. I want you guys to give it a try. Let me know its answer fast. I want you guys to give it a try and let me know its answer fast. So first of all, you have got Cn ligand over here. This is Cl negative, this is H2O, right? What is the order of the strength of these ligands, right? Cn negative, it is a strong field ligand, right? Followed by H2O, followed by Cl negative, right? This is the order of their ligand field strengths, right? This is the order of their ligand field strengths, yeah? Right? Now people, we know wherever ligand is strong, there only splitting will be maximum, right? And if splitting will be maximum, will the intensity of color be more or less? Intensity of color will be less. Wherever splitting is maximum, intensity of color is less, in short, right? And where splitting will be maximum, wherever there will be strong field ligand, there only splitting will be maximum, intensity of color will be less. What do I need to check? The correct order of intensity of colors. Intensity of colors. See guys. See, this is basically the order of the field strengths of these ligands, right? Yes, right? And same will be the order of what? Same will be the order of the crystal field splitting energy, right? Yes. So opposite of this order is going to be the intensity of the colors, right? Opposite of this order. So intensity of color will be maximum where the ligand is Cl negative. Where is the ligand Cl negative? This, then your H2, then your Cn. Question is done and dusted, right? A very simple question, conceptual one. Yeah? So wherever splitting is maximum, intensity of color will be less in that case, right? Remember this in short. Correct? And splitting will be maximum in that case where the ligand has got the maximum field strength, yeah? Perfect. Let's move on to one more question then. This is one more question, guys. Okay, in the following reaction, the reason why meta-nitro product also formed is, okay, why do we get the meta product over here as well? Why do we get it? See, we are carrying out the reaction in acidic medium, right? In acidic medium, during nitration, what happens basically? What happens? What is the reason? What happens? From your aniline, what do we get? We get anilinimine. We get the anilinimine, right? and that aniline ion is basically meta directing. That's why we get the meta product over here as well. And I want you guys to remember these percentages as well, right? I want you guys to remember these percentages as well. This is important. Yeah? Right? So due to the formation of aniline ion, which is basically meta directing, that's why you get the meta product over here as well. Yeah? Perfect. Okay, so the correct order of the following compounds showing increasing tendency towards nucleophilic substitution reaction. Nucleophilic substitution reactions, right? Nucleophilic substitution reaction, the order of their reactivity. The order of their reactivity towards the nucleophilic substitution reactions. So basically a nucleophile is going to attack this one, attack this one, attack this one, and attack this one. Where is going to be the attack of nucleophile faster? What is nucleophile? Nucleus loving species. Nucleophile is going to love the electron deficient species. And which one is going to be electron deficient among all? Over here we have got 3 nitro groups attached, right? Nitro group, it's electron withdrawing group. So electron deficient will be electron deficiency will be maximum in third case. And wherever electron deficiency will be maximum, there only nucleophile is going to attack fastly, right? So just tell me the order now. Just tell me the order. Is it going to be 4? Then comes your 3, right? Then comes your 2, right? And then comes your 1. Simple. Done and dusted, right? 4, 3, 2, 1 is the order. 4, 3, 2, 1 is the order. That means it's option C, absolutely. Yeah? Perfect. Most suitable salt which can be used for efficient clotting of blood. First of all, you should know blood is the negatively charged salt. Blood is the negatively charged salt, right? Yes. And in order to coagulate it, you need to add some positively charged ions as per the Hardy-Schulze rule, right? So wherever the positive charge on the counter ion is more, there only coagulating power is more. Yes, there only coagulating power is more. So which one is the most suitable one? Which one is the most suitable one? Right here you have got Fe tri-positive. Fe tri-positive. More the positive charge, more is going to be its coagulating power, because blood is the negatively charged salt, right? Yes. So FeCl3 is going to be the most suitable reagent which can be used for the efficient clotting of blood. Yeah? Perfect. The ones who have not liked the video, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. Okay. Now the product P will be. It is a nice question, right? And this is the NCERT based question as well. Well, how do we solve this one? So we have got basically ethyl ester. I'm starting with ethyl ester, right? This is CH3, correct? Right? I'm starting with ethyl ester, correct? This is CH3, this is C double bond O, correct? This is O, and this is C2H5. This is something which we call as ethyl ester. I'm making it to react with the excess of this Grignard's reagent, CH3 MgBr, right? This is basically CH3 MgBr, correct? What do we get over here in this case? First of all, in the Grignard's reagent, this carbon will be having delta negative, magnesium will be having delta positive, right? So this carbon is going to attack at this position, due to which this bond will be broken in this way, right? What do I get over here? You get something as CH3. This is C, oxygen carrying the negative charge, right? Already already this O, C2H5 was attached, and now one additional CH3 will be attached. Yes. And people, since this oxygen got negative charge, this negative charge on oxygen is going to attract this positively charged part towards itself. So it's going to be MgBr positive. Yes. Delta positive, I can say. Right? Now, people, what is going to happen after this? Now, what is going to happen after this? Again, since this OC2H5, it's a better leaving group. It's a better leaving group. So what is going to happen? This negative charge will again come here, and this bond will be broken in this way. So what do I get finally? I get something as CH3. This is going to be C. This is going to be double bond O, right? And this is going to be CH3, right? And with this, we get C2H5O negative, and that C2H5O negative is going to attract this MgBr towards itself. So it's going to be C2H5O MgBr, right? MgBr. You get something like this. Now, since I'm using excess of Grignard's reagent, so this substance which I got over here, it will undergo the attack of Grignard's reagent again, right? So let me erase this part. Let me erase this part. Now, what is going to happen? Your CH3, C double bond O, and you have got one more CH3 over here. Now, it will undergo one more attack by this Grignard's reagent. You have got CH3 MgBr over here. Yes. Similarly, the same process is going to happen. This is negative, right? This magnesium is positive. This carbon is going to attack at this position, due to which this bond will be broken in this way. So what do we get over here in this case? It's going to be CH3. This is going to be C, oxygen with a negative charge. It's going to attract MgBr positive towards itself, right? And with this carbon, already there was CH3, now one more CH3 is going to come, right? Finally, once this substance is formed, what do we get? This substance undergoes hydrolysis, and after the hydrolysis, what do we get as the final product? Is going to be CH3C. This oxygen with this hydrogen will be attached. This is CH3, this is CH3, right? This is the final product. Yes? So what is the answer of the question? Look at the options. We got 3-degree alcohol, right? This is the 3-degree alcohol. Let me know if it is clear to everyone. Fast. Yeah? Perfect. Let's move on to one more, guys. Okay, the question was asked in 2015. 20 grams of magnesium carbonate decomposes on heating to give carbon dioxide and 8 grams of magnesium oxide. What is the percentage purity of magnesium carbonate in the sample? First of all, you should know how to calculate percentage purity of the compound in the sample. Let me give you the formula. Percentage purity of the compound in the sample is always equal to mass of pure compound divided by mass of impure sample multiplied by 100. This is the formula which we use in order to calculate percentage purity, right? First thing, what I'll be doing, I'll be writing the reaction. As per the equation, this magnesium carbonate, it is being decomposed, right, into magnesium oxide, and with this magnesium oxide, you have got carbon dioxide as well, yeah? It's a balanced chemical equation, people. It's a balanced chemical equation. Now understand, it's mentioned that 20 grams of the magnesium carbonate sample decomposes on heating to give carbon dioxide and 8 grams of magnesium oxide. Yes, 8 grams of magnesium oxide. What do I need to calculate? I need to calculate the percentage purity of magnesium carbonate in the sample. So first of all, if I ask you, is this 20 grams? Is this the mass of pure compound of MgCO3, or this is the mass of impure sample? This 20 grams, it is the mass of impure sample. This 20 grams is the mass of impure sample, right? Now what I'll be doing? Since this 20 grams is the mass of impure sample, now I'll see how much amount of this impure sample has participated in the reaction. And the amount of the impure sample which participates in the reaction is going to be the mass of pure magnesium carbonate, right? Because in the reaction, only pure substance participates. You know it. Yeah? You know it. Right, people? So how I'll be solving it? Understand? So first of all, what is the mass of 1 mole of magnesium carbonate? That means I'm talking about the molar mass of magnesium carbonate. What is the molar mass of magnesium carbonate? Let's calculate it. Magnesium, its molar mass is 24. Carbon, its molar mass is 12. O3, molar mass 48. 8 to 10, 4, 14. 2, 1, 3, 4, 4, 4, 8. 84 grams. So mass of 1 mole of magnesium carbonate is 84 grams. What is the mass of 1 mole of carbon dioxide? Okay, I've got nothing to do with carbon dioxide. I've got something to do with magnesium oxide. What is the molar mass of magnesium oxide? Magnesium is 24. Oxygen is simply 16. The value comes out to be 40, right? So 40 grams is the mass of 1 mole of magnesium oxide, or you can say 40 grams is the molar mass of magnesium oxide, correct? Now people understand. Can I say from the reaction, from the stoichiometry of the reaction, you got to know 40 grams of magnesium oxide is produced from 84 grams of magnesium carbonate? Yes. So can I say 1 gram of magnesium oxide would have got produced from 84 divided by 40 grams of magnesium carbonate? Yes. So can I simply say 8 grams of magnesium oxide would have got produced from 84 divided by 40 multiplied by 8. The value will be, this is going to be 1, this is going to be 5. 84 by 5 is how much? 5 ones are 5, 5, 16. 16 point something, 16 grams of magnesium carbonate. So you got to know this much amount of magnesium carbonate has actually participated in the reaction. How many I had? I had 20 grams of impure sample. Out of 20 grams of impure sample, only this much amount of magnesium carbonate has reacted. And in the chemical reaction, only pure substance participates. So this is the mass of pure magnesium carbonate. Right? Done and dusted. You got the mass of pure magnesium carbonate, which is around 16 grams, divided by mass of impure, multiplied by 100, solid. That's going to give you the percentage purity, right? Done. Let me know in the chat box if it is clear to everyone. What's going to be finally the answer? Answer finally is going to be 84, yeah? Right? This is one more way of doing the same question, right? You can check it out afterwards in the Telegram group. This is one more way of solving the same one, yeah? Perfecto. Moving on to one more question, guys. Which of the following reagent is suitable for the preparation of the product in the below reaction, right? So if you look at the reaction carefully, guys, if you look at the reaction carefully, you are doing basically the reduction of this carbonyl group into what? Into the alkane, right? You are doing the reduction of carbonyl group into the alkane without doing anything with the double bond. Double bond over here was here, over here again it's here, right? So which one it's going to be? Is it going to be Clemmensen reaction or Wolff-Kishner? Is it going to be Clemmensen or Wolff-Kishner? Tell me fast. Absolutely. I'm not doing anything with this double bond, right? I'm going to convert just the carbonyl into the alkane. Yeah. So this is actually the case of Wolff-Kishner reaction. And what is the reagent which we use in the Wolff-Kishner reaction? It's this one, right? To reduce the carbonyl group into the alkane, Wolff-Kishner reaction is used without affecting the double bond, right? Yes, people? Done? Okay, the total number of linear species, a very simple and chocolate question, I must say. Let me know its answer. I'm not going to solve this. Let me know its answer first. Let me know its answer first. Which one is linear among all? There is only one compound which I can see which is linear. Which one is that? Which one is that, people? Which one is linear among all? There is only N3 negative which is going to be linear, right? All the other three are going to be bent, right? They are going to be bent shaped, correct? This is N2 bent, this is Cl2 bent, this is O3 bent. Only N3 negative is going to be linear among all. So there is only one compound among them which is going to be linear, right? Rest all are bent, correct? This is a very simple question provided you know the structures. That's it. Yeah. Okay, one more question. This year it was asked. This year it was asked, right? So people, see how this question is to be solved. So let's read the question first. 15 ml of aqueous solution of Fe dye positive in acidic medium completely reacts with 20 ml of 0.03 what? 0.03 molar aqueous Cr2O7 dye negative. The molarity of Fe dye positive is. So first of all, before solving this question, let me tell you. Cr2O7 dye negative. Okay, let me write the reaction completely. See, let me tell you, Cr2O7 dye negative converts Fe dye positive in acidic medium into Fe tri positive and itself gets converted into Cr tri positive, and with this you'll be writing some water as well. This is the reaction which takes place over here. This is the reaction which takes place first of all, yeah? Now people, if I ask you, what is the N factor of this Cr2O7 dye negative? First of all, let me represent this by number 1. Let me represent this by number 2. Okay, well, you can simply say N factor of first over here is 6. N factor of second over here is plus 2 to plus 3. Plus 2 to plus 3 means 1, right? You can take it out as well. See, the oxidation state of chromium right here is plus 6. So plus 6 to plus 3. Plus 6 to plus 3. What is the change in oxidation state? 3. 3 is the change in the oxidation state for one atom of chromium, but I have two atoms, so 3 multiplied by 2 is 6, right? Dye positive to tri positive, plus 2 to plus 3, change is 1, N factor is 1, right? Now people, what do I need to do? I will simply equate the milliequivalence of these two. I'll simply equate the milliequivalence of these two. I'll say milliequivalence of 1 should be equal to milliequivalence of second. Milliequivalence of 1 means normality of 1 multiplied by volume of 1 in milliliters is equal to normality of second multiplied by volume of second in milliliters, right? This is the approach. This is the approach, right? Now people, okay, someone is saying, how do you know this is the reaction? People, remember, KMnO4 as well as K2Cr2O7. KMnO4 as well as K2Cr2O7, it converts Fe dye positive into Fe tri positive. It converts oxalate ion into carbon dioxide. It converts I negative into I2, right? It converts H2O2 into O2 in acidic medium everywhere, right? Remember these reactions. That's how I wrote this reaction. Yeah? Now we will see. First of all, what are the parameters we are given for Cr2O7 dye negative? I'm given with the volume of Cr2O7 dye negative and its molarity, right? Its molarity is given as 0.03. Its volume is given as how much? Its volume is given as 20 ml. Similarly, what is the molarity of Fe dye positive that's given to me? Molarity of Fe dye positive is something which I need to calculate, right? Volume of Fe dye positive is given to me as 15 ml. So what is the first thing which I'll be doing? I'll be converting molarities into their normalities. So normality of 1 is going to be equal to molarity of 1 multiplied by n factor of 1, right? Molarity of 1 is 0.03, n factor of 1 is 6, 6 multiplied by this is 0.18, right? Let's assume the normality of second is represented by n2. Now people, n1 value I got to know as 0.18, v1 value was given to me as 20 is equal to n2 value is something which I'll be calculating first of all. V2 value is given to me as 15. So can you let me know what is the value of n2 coming out to be from here? Can you let me know in the chat box? What is the value of n2 coming out to be from here? Can you let me know fast? What is the value of n2? People, can you solve it? Can you let me know exactly fast? Ashwin, this is a shortcut only, bro. Let me know fast in the chat box. What is the value of n2 which you are getting from here? So it's coming out to be 0.24, right? You got the value of n2 as 0.24. But am I supposed to calculate normality of Fe dye positive solution or molarity? I'm supposed to calculate molarity, right? We know normality of second is basically equal to molarity of second multiplied by n factor of second. So I'll say molarity of second is equal to normality of second, which is 0.24 divided by n factor of second. That's 1. So molarity of Fe dye positive solution will be also what? 0.24, right? So 0.24 I'll be writing as 24 into 10 raised power minus 2. So this is something which I was supposed to calculate. So 24 is the answer of the question, right? Yes? Right, people? Okay. One more simple question, guys. In the ground state of iron, the spin magnetic moment is something multiplied by 10 raised power minus 1. Again, a very, very simple question. Well, people, if you look the outermost configuration of iron, which is 3d6 4s2, right? 3d6 4s2. In the ground state, how many unpaired electrons do we have? There are some 4 unpaired electrons, right? There are some 4 unpaired electrons. Let's calculate the spin magnetic moment. Spin magnetic moment is going to be under root of n into n plus 2 Bohr magnetrons, right? So it's going to be equal to under root of n value is 4 multiplied by 4 plus 2 Bohr magnetrons. The question is done. Rest you can solve on your own. 4 plus 2, 6. 6 multiplied 4 is 24. So it's root of 24. Root of 24 is, I guess, 4.83 something, right? 4.83 Bohr magnetrons, right? 4.83 Bohr magnetrons. Correct? Right, people? 4.83 or 4.87? Let me check it exactly. It's 4.89 Bohr magnetrons, right? So 4.89 you can write in this form, 48.9 into 10 raised power minus 1. So instead of this 48.9, you can write the answer. The nearest integer is absolutely going to be 49, yeah? Right, people? Right. You need to be careful with this as well, right? Okay, so one more question. The question was asked in 2012. 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. Okay, if 10 ml of this solution is diluted to 1 liter, the concentration of the resulting solution is, okay, the question is based on the molarity of dilution, right? See guys, how this sort of equation is solved. First of all, what I'll be doing, I'll be calculating the molarity of sodium carbonate solution, which is going to be equal to mass of solute multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters, right? Let me call this as M1, right? What is the mass of solute? What is the mass of solute? Which is 2.65 grams multiplied with 1000. People, you can do the calculation till then. What is the molar mass of Na2CO3? Molar mass of Na2CO3 is going to be 106 multiplied by volume of solution in milliliters. How much? 250. Solid, guys. This is 1, this is 4 times. You can calculate M1 till then, right? You do it, people. You do it fast. Let me know the value of M1 which comes out to be from here. Do the calculation part for me. Fast, yeah? Do the calculation part for me. Let me know fast, guys. So people are saying it's 0.1. Should I be trusting you? Yeah? All right. So if you guys are saying it's 0.1, so it must be 0.1 only then, right? You got the molarity of sodium carbonate solution. Now people, if 10 ml of this solution, see, molarity of solution I got to know as 0.1. I'm using some 10 ml of it. If 10 ml of the same solution is diluted to 1 liter, so final volume of the solution is 1 liter, means 1000 ml, right? What is the resulting molarity, I believe, right? What is the resulting concentration? I'll be using the concept of dilution, molarity of dilution. I'll simply say millimoles of first should be, millimoles before dilution should be equal to millimoles after dilution. How do we calculate millimoles? Molarity multiplied by volume in ml, right? So I'll be simply using the formula M1V1 is equal to M2V2, right? Out of these four parameters, M1 is given to you, V1 is given to you, V2 is given to you, M2 is something which I am supposed to calculate, right? So from here, you will be getting the value of M2, right? That's the equation. Yes? Right, people? So what is the final answer of the equation? The final answer of the equation is coming out to be 1, right? After solving this equation, you get the value as 0.001 molar, but I'm going to write it in the form of A into 10 raised power minus 3. So it's going to be 1 into 10 raised power minus 3. The answer is going to be 1. Yeah? Perfect? Perfecto, right? Wonderful. Okay, I believe this is the last question. People, will you do this question on your own? Or you want me to solve it right now? Choice is all yours. You'll be doing this question on your own, or you want me to solve it right now? Let me know in the chat box fast. Let me know fast in the chat box. What are you waiting for? Okay. Solve now, my God. All right, let me solve it for you. The equilibrium constant at 298 Kelvin for the reaction is 100. If the initial concentration of all the four species is 1 molar, the equilibrium concentration of D is. Okay, let's try to solve this, guys. See, it's a simple equation again, but there might be some calculation issue in this. I'm not sure. Let's check it out. A plus B is giving C plus D, right? At time t is equal to 0, I'm starting with 1 molar of each substance. I have got 1 molar of A, 1 molar of A, 1 molar of B, C, D, everything, right? It's mentioned in the equation, right? So I've got 1 mole, the concentration of each reactant and product at time t is equal to 0 is 1 molar, right? Well, people, Kc value is also given to us as 100. Kc for this reaction is also given to me as 100, right? So at equilibrium, let's assume out of 1 mole of A, X moles have reacted, so I'll be left with 1 minus X moles. This will be also 1 minus X, right? This will be 1 plus X. And this will be also 1 plus X, because already 1 mole of C was there. Now from this reaction, some X moles will get formed. Similarly, it's going to be 1 plus X. This one will also going to be 1 plus X, right? Simple. Correct? Now, it's almost done. I got basically the concentration of each reactant and product at equilibrium, right? The expression for Kc. Kc expression is going to be concentration of C at equilibrium, which is 1 plus X, multiplied by concentration of D at equilibrium, which is 1 plus X. So it's going to be 1 plus X ka square, divided by, it's going to be 1 minus X ka square, right? So just take the square common. So it's going to be 1 plus X divided by 1 minus X ka whole square, right? Is equal to what? Kc. Kc value is given to us as 100. So from here, I'll be getting as 1 plus X divided by 1 minus X is equal to 10, right? So I get 1 plus X is equal to 10 minus 10X. So it's going to be 11X is equal to 9. From here, you get the value of X as 9 by 11, right? You got X. What was I supposed to calculate? I was supposed to calculate the equilibrium concentration of D. What is the concentration of D at equilibrium? Concentration of D at equilibrium is 1 plus X, right? 1 plus X is 9 by 11. So 11 plus 9 is 20. Divided by 11 is the final answer, right? Yes? Done? Dusted? Exactly, it will come out to be something as 1.8 something. I don't remember. That you can do on your own, right? So finally, you're getting the answer as 1.8. Perfect. So people, with this, our tonight's mock test is done and dusted. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. And if you have not enrolled in the crash course yet, do enroll in this, guys. It's going to be beneficial, right? And let me show you exactly how to enroll in the crash course for KVPY as well as mains. Well, people, this is the video which you guys are currently watching, right? You just need to drag the video a little down, click on this show more. After clicking on this show more, what you'll be getting certain links, right? These are certain links, correct? Well, this one, get KVPY SX crash course, this is for the KVPY, right? And similarly, you have got JEE crash course as well. You can click on this as well, right? Okay, let me show you just one. Let me click on this JEE crash course link. After clicking on this, you are just getting this crash course for, I guess, 4K. Yes, you need to drag it down, use the coupon code WSCC, buy now, use the number, everything. You'll get automatically enrolled in the crash course, right? Yes. So people, this was all from my side in the tonight's session. Well, I want you guys to tell you one thing important. Tomorrow morning, 10 a.m. on NEET Elite channel, I'm going to do some 100 questions from the chapter Equilibrium, right? If you think Equilibrium is something difficult chapter, by seeing that session, I'm sure everything will be done, right? You'll find the Equilibrium damn easy tomorrow if you're attending that session, right? At 10 a.m. morning on NEET Elite channel, okay? The level is going to be same for your NEET, and I'll keep the level as JEE Mains, right? So you guys can watch it. So with this, I'll take a leave. I'll see you guys tomorrow then in the morning. Till then, you guys take care, right? Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.